Hello everyone, I hope this video finds you well. I'm doing great, and partly because I'm ready for today, we are going to be doing some straw math. So to explore the first type of triangle inequalities, I've got some Brahms straws, so unpaid commercial here for Brahms. Brahms is delicious. And a pipe cleaner that I'm going to use to make our angles here. This is not a perfect experiment, but it is beautiful. Okay, so I've got 1 inch, 2 inch, 3 inch, 4 inch, 5 inch, and an 8 inch piece of straw that we're going to look at creating different triangles from. So first we'll start with, let's say, a 2, 3, and 4. So first, what kind of triangle would it be if it's 2, 3, and 4 inch sides? Hopefully you said scalene. And in this case, it also looks like it would be obtuse. But what we're looking at is whether we can actually create a triangle or not. So if I have 2, 3, and 4 inches, this does create a triangle. It's beautiful. So what you might be thinking is like, couldn't you combine any of these sides and create a triangle? And the answer to that is no, because say I have, let's go with our 5 inch here. Let's try 2, 3, and 5, and you might already be noticing, now there's going to be some human error here because I'm the one that cut these, and it was not perfect. Straws were flying. If I have 2, 3, and 5, that means that the sum of the 2 and the 3 side are the same as the 5 side. So this does not actually create a triangle. You might see if you can force it. I've got some human error here going along because it looks like my 2 and 3 don't actually add up to be 5. But they should add up to be 5, and that means that it would collapse on itself and not actually create a triangle. We could even do a more extreme situation where I've got my 5, 3, and 1, where when I add these together, I only have a length of 4, so these are not even going to reach. I can't create a triangle with these lengths. It's all very sad. So what we're looking at is that the sum of 2 sides of the triangle have to do with what length will actually work for the third side. That if I have a sum that is less than that third side, that doesn't work. It also doesn't work if my 2 sides have lengths that are equal to that side, and that one doesn't work very well. Let's look at 2 and 2. Oh, I thought that was 4. That was a 3, I guess. So this is a 1, 2, and a 3, and they collapse on each other. I can't actually create a triangle out of them because those two equal the third side. Okay, so in other words, putting this into our notes, if we have some triangle XYZ, then any 2 sides have to have a sum that is greater than the third. Otherwise, it's going to collapse on itself, or they won't be long enough to reach. Does have to be strictly greater than, can't be equal to. So I've got my XZ plus my XY would have to be greater than YZ. My XZ and YZ would have to be greater than YX. And my XY plus YZ would have to be greater than XZ. Or just specific example way of saying that the sum of any 2 sides has to be greater than the third side. So with this, we might be given examples where maybe we're trying to decide if a triangle can exist with those lengths or not. So for A, we've got 3, 7, and 8. So remember, any 2 of the sides have to be greater than the third. The sum has to be greater than the third. So we could look at all 3 situations where we know 3 plus 7 is greater than 8, and so that works. We've got 3 plus 8 is greater than 7, and then our 7 plus 8 is greater than 3. So all 3 of these are true statements, so this would be a yes. Any sum of 2 sides is greater than the third, so it works. But really the only one that we have to check is the 2 smallest sides having a sum that's greater than a third. Because I know if I'm taking a side that's bigger than, like 8 is bigger than 7, so I know that 8 plus anything is going to be greater than 7. And also same for 7 if I'm adding, anyway. So really the one that we're trying to check is the two smallest sides having a sum that's greater than a third. But you could go through all 3 of those if you're not sure. Okay, so same with B. Go ahead and see here if you think 5, 10, and 15 would create a triangle. And hopefully we said no. It does not create a triangle because if I'm looking at 5 and 10, the sum of 5 and 10, 5 plus 10 is not greater than 15. It has to be strictly greater than, it's equal to. This would be one of those situations where the straws would collapse on each other because the sum of the two sides is the same as the third side. So everything's just straight. It is not a triangle. Okay, same thing for C. Decide for yourself. Do you think it could create a triangle or not? And it is a yes. It does create a triangle because our sum of 2 and 6 is greater than 7, and then anytime I'm looking at other combinations, they're a little bit more clear. Of course, 6 plus 7 is going to be greater than 2, and 2 plus 7 is greater than 6. So have to have the sum of any two sides be greater than the third to create a triangle. Using the same information, if I have two sides of a triangle, I can give an inequality or options for what the third side could look like. So if I've got sides of 8 and 12, I know a side of 3 isn't going to work because 8 plus 3 is not greater than 12, so that doesn't work. So there's a trick to this, but let's think through this. If we're wanting on the small end, the shortest that it could be, my straw couldn't be 3 because the sum wouldn't be greater than 12, and it can't be 4 because then it would be equal to 12. 8 plus 4 is going to be equal to 12, but my side could be anything greater than 4. And it's going to be stuck in between two values because we want it to be large enough to where the sum of 8 and 4 are greater than 12, but we also don't want it to be too large because if that third side is 30, now the sum of 8 and 12 is not greater than 30. So that doesn't work either. So on the high end, if we're getting closer to what works, I know that 20 doesn't work because 8 plus 12 have to be greater than that third side. But I do know that anything less than 20 would work because I want the sum to be greater than that third side. So we end up that that third side has to be trapped in between 4 and 20. Anything in between would work. The trick for this is that really I just subtracted these two numbers and then added them. So subtracting 12 and 8 gives us 4, and then adding 8 and 12 gives us 20, because that gives us the side that would be equal. It would make our two smaller numbers have a sum that is equal to 12. 20 would make these two numbers have a sum that is equal to 20, but then we can't actually have that. We want something in between. But that logic is good to go back to what is allowed here. So for E, now that we know a little bit more of a shortcut, we could say, okay, 5 and 16 on the low end, it can't be equal to 11 when I subtract them, but it could be anything greater than 11 will work. And then on the other end, if I add them, it can't be 21, but that third side could be anything less than 21. Okay, so go ahead and try F. Decide what you think it is trapped in between. Okay, so just adding and subtracting, we see that if we subtract the 6's, we get 0. If we add them, we get 12. This might seem like an issue that we would have 0 in our inequality, but we're saying that x has to be greater than 0. So anything greater than 0 would work. So that means we could have, that's a very tiny triangle. I meant to actually make space between them, but my marker was too thick. That means I could have these sides of 6, and then that third side could be 0.1, 0.2. It's a very skinny triangle, but it still exists. So making sure that that third side makes any sum of the two sides greater than the third. The other inequality that we're going to look at in triangles And well, the first one was kind of common sense. I feel like this is even more so common sense, but maybe something that we haven't thought about before. That if we're looking at a triangle, we can know by the angles which side is the shortest and which side is the longest. I can also know by the sides which angle is shortest or smallest or largest. So looking at this figure, and we can go off of looks sometimes, but we don't want to be tricked here. So we're going off of numbers, looking at our angles and trying to decide what has to be the shortest side, what has to be the longest side. So if we think about this, if I've got a small angle, it is closed more. So if you've got a 20-degree angle, looks like this. Notice that the side opposite that 20-degree angle is fairly short. If I make the angle wider, the distance between their ends gets further apart. If I make the angle obtuse, now those ends are really far apart. So if you're talking about one triangle where all of the angles relate to each other, they're all adding up to be 180, then if I have a 20-degree angle, my smallest angle in this triangle, it has to open up to the shortest side. Because for angle B, now this is a larger angle, it is going to open up to a larger side. So our shortest side in this triangle is going to be across from the smallest angle. B. So in this case, our shortest side is going to be AB. So shortest. If we wanted to know the longest side, we would look across from our largest angle. So the 110 is going to open up to the biggest side, and so BC would be our longest side. So we might have something where we're trying to list the sides in order from shortest to longest, or vice versa. Maybe we're looking at the sides and trying to go from sides to angles and list them from smallest to largest. But the same concept is true. You're going to look for that shortest side. It's across from the smallest angle. Longest side's across from the largest angle. So for number one, if I'm trying to order these from shortest to longest, the sides from shortest to longest, the first thing that I would need to do is go ahead and solve for that last angle. Because if I'm comparing these and trying to make sure that I have the shortest side across from the smallest angle, then I have to know that I'm looking at the smallest angle. So subtracting from 180, we would get that that last angle is 92 degrees. Oh, that doesn't make any sense. What did I just do? Oh, I put 44. I put 44 twice. That doesn't make sense. 88. 88 degrees. That's much better. So our 44-degree angle is the smallest angle. So that means it will be across from the shortest side. So if we're going from shortest to longest, we've got QP. Our next longest side will be across from the next largest angle. So across from 48. And it does help some students to draw an arrow to the other side. If that helps you, then do that. So it's across from QM. And then our largest angle is across from the longest side. Okay. That would be from shortest to longest. So go ahead and try on your own here. If you want to start with the diagram, you can. You can actually answer this without a diagram, but either way, you are trying to list, same question, trying to list the sides in order from shortest to longest. Okay, so if we started with a picture, and our picture doesn't have to be perfect, it does help if it's a little bit to scale. Let's see, we've got our G is 100, but mine's looking kind of isosceles, so it is not very to scale. But let's see, my 50 was E, and then my 30 is F. Okay, so I could start with a diagram, and then I'm answering it just like number one, that I know the shortest side has to be across from the 30-degree angle. So GE has to be the shortest side. Across from the next largest angle, E would be GF. And then our longest side would be across from angle G. We didn't have to necessarily draw a diagram for this situation because it is a triangle. So if I know that the shortest side is across from the smallest angle, then I could say, okay, well, my smallest angle is F, so that means that angle F does have to be across from EG. I didn't have to draw it necessarily to know that that was true. Okay, so those are our two triangle inequalities. The last thing that I want you to do, just see who all is participating here, and maybe we'll catch some of those that are not watching the videos, keep them on their toes a little bit. I want you to comment on the post from today. You are going to share the name of your first pet, and that's it. No explanation, just like fluffy in the comments for today. We'll see what happens from doing that. You guys have a great rest of your day. See you guys.